Hey guys, welcome back to my channel, The Math Pad, and today we'll be diving into more algebra questions. The topic for today would be rearranging the formula. So when you talk about rearranging the formula, basically we're talking about changing the subject of the formula. Initially in the question, they would give you some other variable as the subject of the formula, but in the solution, they would ask you to rearrange the entire thing and make another variable subject. So keeping that in mind, let's begin with the first question. So it says make x the subject of the formula. The equation is y equals to square root of x squared plus 1. So as I said, the initial subject of the formula is y, but they're asking us to make x the subject. So in order to make x the subject, what we will do is we will try to isolate x step by step. And when we're trying to isolate x, basically what I mean is that we're trying to make sure that x is alone on one side, whereas every other term or operation happening on the side of x is happening on the other side. So first thing first, we need to get rid of the square root on top of x squared plus 1. So whenever we try to get rid of the square root, what we do is we square both sides. So what I'm going to do is I'm going to square y, and I'm going to square square root of x squared plus 1. If you remember the rules of indices, for example, if we have square root of x being squared, the power square root basically represents the power of 1 over 2, which means if we rewrite this, it becomes x to the power of 1 over 2 whole square. And keeping in mind the rules of indices, when there's a power inside the parentheses and there's a power outside the parentheses, those two powers get multiplied to each other. So 2 times 1 over 2 is basically 1, and x to the power of 1 is just x. So keeping all of this in mind, when we square both sides, y to the power of 2 becomes y squared, and square root of x squared plus 1 becomes x squared plus 1. So whenever you're trying to solve, indices or like getting rid of square roots, you're going to keep these steps in mind. Anyhow, so y squared equals to x squared plus 1. Now, since we've gotten rid of square root on top of x squared plus 1, we move 1 to the other side. So it becomes y squared minus 1. The reason why it's y squared minus 1 now is because 1 was being added on the right-hand side. But since we've shifted it to the left-hand side, so its operation changes. So if it was being added on the other side, it would get subtracted. If it was initially being multiplied on the other side, it would get divided and vice versa. So just keep in mind when you're moving a term to the other side, whatever operation is performing on one side, it performs the exact opposite on the other side. So y squared plus 1 equals to x squared. Now you might think, oh, this would be the solution because x squared is like, isolated on one side. But if you go back to the question, it's asking us to isolate x. We have to make x the subject, not x squared. Hence, to get rid of square on the x, we will square root both sides now. So it would become y squared of y squared minus 1 equals to square root of x squared. Same thing over here. When you square root a square term, it becomes the term itself. So x equals to square root of y squared minus 1. The next question says y equals to p squared plus qr. And it says find y when p equals to negative 5, q equals to 3, and r equals to negative 7. So in this case, initially they're asking us to find the value of y when p, q, and r have these values. So what we will do is we will just substitute the values in the formula. P is replaced with negative 5, q is replaced with 3, and r is replaced with negative 7. So what we have over here now is 25 minus 21, because 3 times negative 7 is negative 21. 25 minus 21 is 4. Y goes to 4. Then it says write P in terms of Q, R, and Y, which means we are trying to make P the subject. So what we will do is, in the initial equation, Y is the subject, and the equation is in terms of P, Q, and R. So keeping this in mind that we have to make P the subject, first you move the other terms on the left-hand side. Since Q and R are already being multiplied to each other, we can directly move them towards the left-hand side altogether. And what would happen is that instead of being added to Y, they would be subtracted from Y. So Y minus QR is equal to P square. Now, we have P square isolated on the right-hand side, but we need P instead of P square. So as we did previously, to get rid of the square, we will square root both sides. So when we square root both sides, final result is Y minus QR equals to P. And that is your answer for part B. Similarly, if you look at question number 3, it says make B the subject of the formula. Once again, as we did previously, there's a square root on the right-hand side, and we need to get rid of that first. So keeping in mind that B has to be the subject, we will square both sides first. When you square both sides, B becomes C square, and square root of A square plus B square becomes A square plus B square. Next step is to get rid of A square because we need to isolate B. So we will subtract A square from the left-hand side, because on the right-hand side it was being added. So if we move it to the left-hand side, it's going to form the opposite operation. So what we're left is C square minus A square equals to B square. Now the only thing we need to get rid of is the square on top of B. So for that, we will square root both sides. So the final answer is square root of C square minus A square equals to B. Next, if you look at question number 4, it says to simplify the expression. So we expand into brackets, but in this case, what we have is indices. So each variable has a power, and when you expand the brackets, we're going to apply one of the rules of indices. So first, what we're going to do is expand the bracket. Like we did last time, a to the power of 1 over 2 gets multiplied with both the terms in the second bracket, and then negative b to the power of 1 over 2 gets multiplied with both the terms in the second bracket. Hence, we're going to begin with a to the power of 1 over 2 times a to the power of 1 over 2 plus b to the power of 1 over 2 minus b to the power of 1 over 2 brackets a to the power of 1 over 2 plus b to the power of 1 over 2. So a to the power of 1 over 2 gets multiplied to a to the power of 1 over 2, and b to the power of 1 over 2. Then negative b to the power of 1 over 2 is getting multiplied with positive a to the power of 1 over 2 and positive b to the power of 1 over 2. So if you remember, one of the rules of indices is that when you are multiplying two bases with this two similar bases with like different powers or same powers, what happens is that the powers get added to each other. So keeping in mind that when you're multiplying two similar bases, the powers will get added. In the first case, since a is the same for both these terms, so we will add the powers. In the second case, since the bases are different, so it just remains a to the power of 1 over 2 times b to the power of 1 over 2. We can't further simplify it. Similarly, b to the power of 1 over 2 times a to the power of 1 over 2 over here remains the same as well. However, for b to the power of 1 over 2 times b to the power of 1 over 2, we will combine the powers by adding them. So this becomes 1, a to the power of 1. And if you can see over here, these two are basically like terms. So as we did last time, like terms can be combined. And in this case, one term is positive and the other is negative. And since the same term, so they'll get subtracted and the result would be 0. And b becomes b to the power of 1. The final result is a minus b.